Hello everybody, this time we're going to get busy with this library up here called XState. There's already a very cool playlist from the Stately folks. It's a 15-minute playlist, I think, from Pocock. So it's an awesome library to orchestrate state in JavaScript. It's great for complex states on applications. And we're going to do a little bit of a twist. I'm not going to do anything like framework specific. If you're a React developer, I totally recommend to check out Matt's playlist because it's very thorough. Instead, we're going to be writing it in plain JavaScript with the XState library, and we're going to be writing some unit tests using I need to get out of the way. This very awesome unit test framework that's powered by Vite. It's called Vitest, which I love a good pun. And yeah, this framework is amazing. So without further ado, let's jump right in. And here we are opening this repository that I just created. The link of the repository is down below. It's open source on GitHub. As you can see, this is just like a contrived example of our state machine. And we have a few tasks that are basically for running Vitest. And just a prettier test. I try to keep the configurations as minimal as possible. You're going to see here it's just like excluding the machine that I wrote before, and I set the mocks to reset on every test run. We're going to talk a little bit more about that further on. Besides that, it's just a plain Vitest config, which is straight from the docs, basically. Besides that, I'm using npm, and I have a short README for you where I'm explaining a little bit of what is the stack that we're using, some stuff we're going to see, and yeah, spoiler alert, I'm going to use the stately VSCode extension to generate some types and what are the reasons for each one of them. And I also put here some cookie tips, which are essentially the concepts that we're going to be working on with in this video. If you're not familiar with state machines, there are a few words that I'm going to be using throughout this video, so you can stick together if it's the first time of you watching anything about state machines or hearing about state machines. The states are basically the checkpoint of the machine. Think about just like random like state. It's where your program is at the moment. That's what they're supposed to describe. We have events, which are the things that are going to happen that's going to move your machine or your program from one state to another. So essentially they're described by user interactions or something like that. We also have actions, which are essentially one-off executions. So they don't actually bring any side effects to the machine. In fact, the machine doesn't really care if they ran successfully, if they didn't. It doesn't change the state. It can add data to the machine, like assigning to the context of the machine and whatnot, but essentially they are not migrating from one state to the other. There are situations where they run, and yeah, they are important. We're going to see throughout the example, but essentially actions are one-off executions that the machine doesn't really care about when they finished, how they finished, and so on. We also have guards, which are conditions that will determine which state your machine is going to transition towards. So basically, think about them the same way you think about type guards or conditional statements. So it's an if-else, it's going to be a Boolean. If it's true, it's going to target certain state. If it's false, it's going to target some other state. And we have services, which are asynchronous API calls usually, and they will affect the machine behavior. So you have they trigger an on done or an on error, and based on that, your machine will go toward that or not. So it's basically how you invoke a service, and that service is going to, in the end, call out an event that's going to transition the state of your machine. And with that, we are good to go. We are going to get started with our physical shop example. So basically it's going to be a very contrived example. We're not going to be like doing any real world code, but what we are going to do is basically mimic what is like a simple interaction, and we're going to be using all these concepts in a way of, it's basically a show and tell. It's a very practical guide, but I also intend to keep things short. So let's get on. So we have essentially three files that we're going to be caring about a lot. in here. So the first one is the machine test. The second one is the actual machine. And the third one are the types for that machine. So the types that we're going to be creating to generate, to let the type generation actually work. And to get on with that, I'll just run, we're using npm here. So I'm going to run npm run test, make my font a little bigger. And you're going to see we have now 8 tests that are pre-written and passing. We define a little bit of the conditions of our test here. So we have what I call the happy path of the machine, and we got some failsafe because we're going to be dealing with some errors. This test is essentially running Vitest, which Vitest by default run with the watcher. So yeah, that's what we're doing. On the pipeline, you run Vitest with Vitest run, so then it runs a one-off. So yeah, let's get started by writing some types, and you're going to see the amount of types that we need to have a fully type-safe machine, state machine, is just this. That's what I had to write. Everything else is essentially the XState library and the stately VSCode extension doing type generation for me and making sure everything works. So these few lines are what I did. So basically I'm creating the external order, and I define this as the shape of my object. So it's going to have an ID, it's going to have an RSU, which is very common for e-commerce and stuff like that, for shops, and it's going to have a product name because that's what I'm going to be using essentially. And we have the context, which is the object that our machine is going to carry out throughout every state. So these are information that's basically always available to our machine. So is it a shop? We have a stock, which I'm mimicking here as just an array of strings. And we have the customer data, which we're going to be creating later on. So it's a record from a string to a string, or it can also have a number. And the customer request, because the state machine is basically going to be working as, think about it as a shop. Customer comes in, makes a request, and then the salesperson is going to react to that request, and we're going to have some events that will happen from that. Here are the events we're going to be throwing. As I said before, it's a very contrived example. So we have the customer request event that's going to be carrying obviously the customer request, which is a string. And then we have either the has available event or the not available event. And for the services, we have this order external services, and this is the shape of XState API. So the data is what the shape of the service are going to always return, and then the data can be anything else. So as you can see, it's an external order, which is the thing we defined in the very beginning. So with that out of the way, we are ready to get started with our machines and our tests. So let me sort of in a TDD effort, let me show you a little bit what we have for our tests. So we are importing a few methods from Vitest. We have the after each, which is going to run after every unit of our test. We have the assert, which we're going to be using soon. And you see that it's not being used because we're going to be writing together, but I already left it imported so I don't get confused with all the imports and everything else. We have the before each. We have a describe, which you can see I'm using here. We have the expect, which is another way of asserting some stuff. We have the test, because that's essentially how we declare a new unit. And we have the VI, which is an object that we're going to be using to create our mocks. And these are mocks, if you're familiar with Jest and not with Vitest, essentially the same thing. I'm calling them counters because essentially that's what I'm going to be using them for in this case. You're going to see real soon. So going further, we have the happy path, which is essentially if everything works, if I have no like unexpected issues, our machine is going to start from the idle state, and it's going to be idle until the customer request events happen. So whenever what we're going to do here is essentially we're going to interpret our machine, get it started, and we're going to send the customer request event and check if it went to the right state. Further on, we have when a customer request fires, we want to have the store request counter function triggered. And that's what we're going to essentially be checking. After that, so when they have available, the salesperson is going to deliver it for the customer and they're good to go. When not available is fired as an event, we are going to go to order online state if the has in stock guard returns false. Or whenever you're not available, it's going to go to deliver if has in stock returns true. So basically, think about it, checking on the counter, going the backstage or whatever we should be calling it on the backstock. And if it's there, they're going to come back and yeah, I found your shoe. That's it. And you go your merry way. And if they're not, they're going to order online for whatever warehouse they would have, supposedly. So that we're going to order and store the customer data, so we know how to call back to the customer when the product's not in stock. And that's essentially like a contrived example of how it is in a real world with real people. But yeah, we're going to draw a state machine out of that. And then we have this little failsafe, which we have the before and after each on test run, and we essentially have two test runs. So whenever the on error fire for the order external, it's go to the product unavailable because yeah, basically we cannot check it if there is. And if the product's unavailable, we're going to give like 2 seconds and we're going to throw our machine back to the idle. And that's our tests. So for now we can actually just have VSCode here, clean up some real estate, and let's get started. So the first thing we gotta do is import the create machine and the assign, which is what we're going to be using. So assign is to assign some data to the context, and the create machine is how we're going to get started. So we're going to export our machine, and we're going to be using the create machine method. And that create machine has the following signature. First of all, we're going to pass it an ID, which I'm going to call shop. Oopsie. Then we get the schema, and the schema has a context, which we're going to be using this signature to define the schema of the context. So essentially it's the type we already created. Same for the event, and same for our services. And as you can see, this has already popped up, which is this VSCode extension here, the XState VSCode. Of course, the link is down below in the description. If you want to just install it, go ahead. But for now, let's keep it like that because it's still not ready to see what we have there. And then we also need an initial state, which is going to be idle. And as you can see, TypeScript's already squawking at me because we don't have that state. So the first thing we need to do is create our states object, and we need to add idle. So that's already enough to get TypeScript a little bit more quiet. That idle is going to on our customer request, it's going to call the store request action, and it's going to point to our check floor state. And again, it's squawking because we don't have our check floor state. And it's still squawking because we don't have that action. So let's get on and get started with our action. So it also takes a second parameter where we're going to declare our actions, we are going to declare our services, and we are going to declare our guards here. So now we have the customer request, store request, and now we need to start creating our actions. Before we get done that, we need to generate the types for the events that we have here and for the internal methods. So in order to do that, we're going to be using our VSCode extension. So what we need to do is basically just declare the types here, assign an empty object, and that's about it. Once we save it, the VSCode extension is going to generate this file, machine.typegen.ts, which has everything that we already created. It's going to define what are the types, what are the actions, what are all the possible events, and the states that it can match, and it's going to assign to our machine. So now we can start doing stuff and we can continue to implement our machine. So what the action is going to do is create this store, and this store request is going to use the assign method. The assign method is going to receive a context, and it's going to receive an event as the first parameter. And as you can see, the events already here. I have a customer request and the customer request of type event, and the customer request event carries this customer request, which is essentially what I need to return. So I'm going to give the customer request. It's going to be the event customer request. And that's basically it. So we already assigned something to our context. So whenever this event calls, state machine XState is going to run this store request action, which is going to assign the customer request to the context, and it's going to be available throughout all the states of our machine. So moving on, now we have the check floor, and the check floor again has the on. So it's a listener for the events that we can have, and the first one is going to be on available, and the second one is going to be on available. And as you can see, the first one doesn't have any condition, so it's going to be only targeting one event, while the other one is going to have a condition, so we're passing an array of events. So the has available is going to target deliver, and that's about it. And again, my machine started squawking because deliver was not a state. Back at it, we have our first target for not available, and they run in order. So the first one needs to be the one with the condition, which is going to check for if it has in stock. If it has in stock, we are going to deliver, and that's it. If it's not on stock, it goes straight to the second one, which is going to be order online. Again, order online doesn't exist, so for TypeScript to not complain, we need to add a state, and that's it. So now we can go and implement our guard. Our guard is going to be, as we named, has in stock. It's going to receive the same, it has the same signature as assign, but we're only going to be using context now, and we're going to check if the stock that we have in context has our customer request. And to be honest, we have so much type safety, we know that's going to be defined because we added in the action below, and it was a requirement for the event to fire. So I don't even need to add to use the optional chaining here. And that's about it for this part. And now we just need to start to go on. So we already created all this, and I think with that I can actually show you the inspector, which is pretty awesome. So as you can see, we have here our first thing. Our machine starts with the idle state. So we fire the customer request, and then if it has available or if it has in stock, it goes to the deliver state, and the deliver state is not implemented. But essentially that's it, and I'll keep it open here as we go on. And you can also use the editor on XState. Check the link below, and essentially if you're more of a drag and drop person or a no code person, you can actually create almost everything off the state machine with the editor. I'm just more used to this one, so I'll just stick to this. But I really recommend you, again, to go to the Matt Pocock video where he uses that a lot. And let me check. We need to do the deliver, which is a pretty straightforward state. We are going to define this as our final state. And as you can see, the extension is updating as I type. So I set it as final, and then it adds the mark on the state chart. So now that we have the order online is going to be invoking our service. And the invocation of the service takes a source, which is going to be our service order external. And then it's going to have the onDone listener and the onError. So the onError is going to go straight to a product unavailable, while the onDone is going to go to, it's going to run our actions to store the customer data. Oops. Get really bad at typing when those wavy red lines show up. And then we go to stock product. So now let's create our state, stock product, and what was the other one? Product unavailable. And that's it. So now we have our state machine updated. So as you can see, it's everything working. So non-available, and then we go again straight there because nothing is implemented properly yet. So let's create our service. So the order external service is actually going to be an async method, and as any async method, it's returning a resolved promise. It's going to return a promise, and the ID is going to be this. Remember, we created the RSU, and you see TypeScript's already playing its thing. And we have our RSU, which is usually like our hash or whatever, and the product name. It's my incredible product. And that's about it. So now we have a service, stock customer data, stock product, and we need to implement now the stock product. Every time we enter the stock product, because we know it's coming from the order online, we want to actually store product to the context, which means we're adding it to that stock array that we created right in the beginning. It's already there in empty. And once we do that, we set a new listener, which is basically a timeout. So after 3 seconds, we are going to go back to idle. And that's it. We already stored. The customer data. We already made the product. We already ordered the product. Already came, and we are storing it to context. And yay, that's it. And now our last state before we go on testing is the unavailable. And in most cases, you want to have like a state for resetting your state machine, but yeah, essentially it's another state where it's going to ask for a user interaction, and then you can go back and reset the machine. But in this case, we don't have it, and yeah, essentially once the user goes out, you're already available. The customer goes out, the salesperson's already available. So after 2 seconds of a product unavailable, we're back to idle. And oh yeah, we need to implement the product to context action and the store customer data. So product to context is going to again assign, and it's going to take the context and the event. It returns an object. We're going to take the context and the event, and it's going to get like this talk, add everything that's already in the context, and pass the data of the product name. And as you can see, this one has data because it's coming from our service, while this other one, it's coming from essentially our user interaction. So the signature is a little bit different in this case. And our last one, so we can go testing, assign, and context event. And now we're going to get the customer data, and we're going to pass this event data. And that's all we got. So all done. Coolio, everything should be working. So we're idle. We get the customer request, it's checking floor, available, we deliver. Again, we're idle, not available but have in stock, deliver. So now that we're done, we can get ready to testing stuff. So the first thing we're going to do is actually create our mocks. So because we already have like this, we're not in a real world, the mocks look exactly like the things we've written. So I'm just going to recreate them. The only difference is that instead of letting it call just a method, I'm going to pass now the VI function, so we can count, so we can basically assess if those actions were called or not. So that's the only difference, but essentially I'm not going to walk you through the whole logic. You see that the type signature changes a little bit because we're actually running something on. But yeah, feel free to check the code. Essentially the logic is the same. It's just that we are now calling the VI method, so they get called up. And I need to add XState. So yeah, that's basically it. So now we have our mocks and they're on the same file. Besides that, and the reason why I have two suites of tests here is because each one of them are going to use the services different, because one service, and that's basically mimicking a real world scenario. I could just copy the thing that we already created and put it here. But what I actually want is to pretend that I'm testing a real request. So I'm going to create a mock just with what I need. So in this case, the services are going to be just a success handler of our order external, again with the counter, and that's it. And now we're ready to start creating our machine. So I'm going to add it here, the variable because of scope, and then on the before each, I have my machine, which is going to be taking the original machine with a config. And obviously we need to import from machine, and we're going to import a machine as original machine just so we disambiguate. So now I'm passing my services and the actions that we already declared. And just as a good practice, when you're testing state machines, every time you're done with it, you actually stop. And yeah, so, and before you start, you actually we need to interpret the machine. And this needs to come from XState. So this is a method that we basically interpret the machine, and now we have the service that we can start, stop, send events towards, and so on. So the first one that we want to start is check if idle request. If when idle, we get the customer request and it works. So first thing we need to do is start the machine. Last thing we want to do is check if our service state matches check floor. And we save it. And yeah, and it fails. So now what we need to do is service send, and we're going to send a type of customer request, which is going to have our customer request there. So now once we save, that's it. Here we go. First test done. And now the second one. So the second thing we want is when a customer request fires, we store the request counter must be triggered. So the action must be triggered. Then again, remember our service is stopping on each and every one of it. Start the service, and again we're going to set to send it, and we want to, we expect this counter to be called. And that's it. And we can even go further on and say we expect it to be called only once. And there we go. If we go then twice, it's going to fail. So that's a nice way to make sure that our tests are only being triggered once. And here's actually why it's better like this. So if we had, for example, to be called, and we are not resetting our mocks. So see, it restarted and the test pass because we're only checking if it's called. But check this out. Now it's failing because the first one sent a state, so we have one call to the action, and now the second one is calling. So our use case is actually proper. The problem now is that our tests are leaking to each other. So in this case, let's say if I had it like this, everything would be passing, and we could actually have a regression where this thing is not firing at all and our test still passes. So that's a good practice. I think I recommend to always have it by default like this, which is not actually how Vitest do. So by default they're not resetting the mock, but I think we should have it. And as you can see now, triggering and passing, and that's it. So I recommend it like this. And one more. So now when has available fires, we need to go to deliver. So it's essentially the same test as in the previous one. The difference is that now we're passing the state we want our machine to be at to the start. So we don't need to always start and make the whole use case. That would be really bad to test stuff. So we are sending the first state, and we're actually checking if has available is there, and then we assert. So, and when it's not available fires, we want to go to the order online if only has stock is false. And then again, this one is pretty straightforward. And so our test just caught a bug that I skipped. So our stock actually needs to always be there, which I didn't add. So now we have the stock as a valid array, and this is actually now the same test as before because our context is empty at this point. And yeah, it's going to be going straight to order online. So which is not the same for our next test. So in this case, we need to interpret a new machine. So we're going to create with this special context. We take the original machine, we pass again the ifconfig helper. It's going to be taking the same parameters as before, so the services and the actions, they're all the same, but we pass a second object, which is the context. That's going to be the customer request, that's going to be a test, and the stock, which is also going to be a test. So in this case, it's going to have what the customer is expecting. And then we take the service with the context, so we're interpreting our machine with context. We start from check the floor, and now everything is there. So then we should be going to the deliver state, and that's it. So then again, if we are not going to deliver, we can go to idle, and it's going to fail. So yeah, our test is working. Sometimes we need to double check. And now this is the most special case. So we are going to have more than one assertion on this one, and this is actually an asynchronous test. So in Vitest, we can declare an asynchronous function, which is going to be returning then the done method, pretty much in the same way as for jest. And now we have to start our service, and we're going to again start from check floor. And now we're going to add a new listener for our service. So every time it transitions, it's going to be taking the state. And if our state matches stock product, if our state matches a stock product, we want to assert that all the methods that should be called are going to be. So in this case, we are going to be checking if it has ordered from external counter. We want to check if the product context, if it's going to add the product context to the context, and we're going to check if it's going to store the customer data. After that, it should return to idle after our timeout. So if our state matches idle, we go to done. So now we're going to hold on, and by default, Vitest is going to take 3000 milliseconds to timeout. So if you do more than that, you need to reset, you need to change the timers accordingly. And our test has failed because we have not sent the event, obviously. So let me go back here, and there we go. So now we have our happy path fully tested. What's not covered by the test is definitely covered by our type definitions. So we can get started with our, what I call the failsafe, which is the error paths. So again, now the services are going to be different. we are going to be creating, and we're going to be throwing at them. So we count that they happened and we throw a new error. So we're throwing a new error, but not passing any like super descriptive, well done error. And again, in our before each, we are doing the same thing. The difference that now we're getting this erroring function, and the after is going to be the same as our service that stopped before. And now we have two cases. When the error fires from external, we go to the product unavailable, and then after 2 seconds from product unavailable, we should go back to idle. So in this case, we're going to wrap our test in a try catch. And I don't really care about the error that's being passed to our try, to our catch. So I'm going to start it with the check floor, and I'm going to send our not available. I'm going to send our not available event, and then on the catch, I'm actually going to assert if the product's actually unavailable. And that's it. So now, again, it's an asynchronous test now because of the timeout. So we need to pass the async, and we get the done as a parameter. We need to run inside our event listener. And now, if our state matches idle, we are going to be done. So now that our listener is set, we can then start our service. And we're going to send our not available type. And bada bing, all our tests have passed, and we have successfully tested our state machine. So yeah, that's about it. And I hope you folks have enjoyed it, and I'll see you on the next one.